Hi students, today we are going to learn about types of vibrations. Okay, so we have three types of vibrations: free vibrations or natural vibrations, damped vibrations, and forced vibrations. Okay, as you can see from the names also, free means it is free to vibrate. There is no other external force which is trying to control it. That is when we say it is free. Okay, next vibration is damped. As you can see from the word itself, damped means which is being made lesser and lesser. Okay, that is when the frequency becomes starts to decrease continuously, we say it is damped vibration. Next is forced vibration, means there is some external force. Okay, when you are studying also, when you study very freely without anybody to control you, then you say free vibration. So let us see what is free vibrations. See here, you can see a mass is hung from a spring. Okay, as you can see here, and you just stretch it and release it. Then what happens? It is free to move. This is called free vibrations. Okay. Now when you see here, there is no external force actually. We can say it is just vibrating with its own frequency. But usually it does not happen when we are vibrating it in air. Why? Because the air will try to stop the motion. So free vibrations we can get only in vacuum. Okay? Otherwise it is not possible actually to get free vibrations, because when the body starts vibrating, maybe it is free to vibrate. But then when it continues to vibrate, then it becomes damped in the course of time. Okay, so let us see what is free vibrations. The periodic vibrations of body of constant amplitude in the absence of any external force on it are called free vibrations. So when we are talking about free vibrations, we have to see that the body is vibrating without any interference. Okay, so if the body vibrates without any interference, then it may have a constant amplitude. You can see in the diagram also that it has a constant amplitude. Okay, then how are the free vibrations? They are simple harmonic vibrations under restoring force, the amplitude and frequency of which remains constant. So they are periodic and they repeat after a fixed interval of time. Okay, so these vibrations, they have a, what is the special characteristic? They are simple harmonic vibrations, and they actually are happening at a constant amplitude, and the frequency is also constant. Okay, so this is the characteristic of free vibrations. Then once a body starts vibrating, it continues its vibration with the same amplitude and same frequency forever. Just like we think about Newton's first law. What does Newton's first law say? That if you set a body in motion, it will continue to move, okay, with the same velocity forever and ever. But actually it does not happen. Why? Because of the friction. There are frictional forces, there is air resistance which try to stop the body. In the same way, when we talk about free or natural vibration, we can say that if a body is set into motion, okay, like if we pluck a string, then the string should continue to vibrate forever, but it does not happen because there is resistance of air. Okay, so this is about free or natural vibration. So remember, what is free or natural vibration? The vibration of a body in its own natural frequency without any external force acting on it. So that is called free vibrations. Okay, so this you can see here how the free vibration is taking place, and also when a diagram is asked free vibration, you should be able to show what is a free vibration. The vibration with constant amplitude. See here, the amplitude is constant. You know what is the amplitude, isn't it? The height to which the wave is rising, that is the amplitude. Okay, and the frequency. So amplitude and frequency is remaining constant. That is why it is of the wavelength is constant. Here there are some examples of natural vibration. Okay, very beautifully shown here. See, the pendulum is vibrating. So when a pendulum vibrates, okay, you can see what is the formula given for the frequency. F is equal to 1 by 2 pi then square root of G by L. So it depends on length. How does it depend on length? Last year you have studied. F is inversely proportional to square root of length. So when length increases, frequency decreases. Okay. So this is about the pendulum. Remember that when a pendulum is displaced from its mean position, it starts vibrating. If there is no air, if it is vacuum, it will vibrate with its natural frequency. And that frequency, the formula, you know, it depends on the length. More is the length, less is the frequency. That is why in summers we say the clocks lose time, isn't it? So this is about the frequency of a pendulum. Next you can see here there is a mass which is suspended from a spring. So what happens? The spring will vibrate. Okay, the spring is vibrating with its own natural frequency. So in this case, the time period is equal to 2 pi under root m by k. Okay, or you can say that is a constant there. So frequency is actually 1 by 2 pi under root m by k. So frequency is inversely proportional to square root of mass. Okay, so here also when mass is more, you know that it will go longer. Okay, so that is about the spring here in this case. Okay, next you have tuning fork. You have seen a tuning fork also, isn't it? Tuning fork, when the prongs we struck them, what happens? They start vibrating with the natural frequency. Okay, so that is also about the tuning fork. So you know that tuning fork also vibrates with its natural frequency. So these are all examples of free vibration. You see a flute also. A flute is a wind instrument. So in flute the frequency is inversely proportional to the length of the air column. Okay, so here in the flute we adjust the length of the air column by closing the holes. Okay, so Parthiv will be very interested, isn't it? So Parthiv, when we are playing a flute, we keep on closing the holes. Okay, so that we are changing the length of the air column. So frequency is inversely proportional to the length of the air column. So when the air column increases, the frequency will decrease. Then you see the stringed instrument. In case of a guitar, whoever likes to play the guitar, okay, you will be very interested. That I have told you also in the class that in case of frequency, frequency of a guitar or stringed instruments depends on the length, inversely proportional. Okay, more is the length, less will be the frequency. It also depends on the tension. Tension, it is directly proportional. That is, tighter the string, higher will be the frequency. That is why people tighten the strings of musical instrument to tune it. Okay, so when you tighten it, it will produce a certain frequency. Then it is also dependent on the mass, okay, and also the area or the thickness of the string. That pi r square determines the area of cross section of the string. So thicker string, less will be the frequency. So in guitar you see there are strings of different thickness. Okay, so that is about the guitar. So remember what are the factors on which the frequency depends. The length, then the thickness of the string and the tension. These are the three things which we alter when we are playing to different frequencies on a guitar. Then we come to the ways of vibrating a string. See, a string can be vibrated by plucking its middle point. When we pluck the middle point, then the string vibrates in one loop. You can see here the first diagram. See, this is how the string will vibrate. So in that case, we will say it is the natural frequency of the string. Okay. We can also pluck it 1/4 at a point 1/4 from one end. So it will then vibrate in two loops. You can check it by using a rubber band and plucking it from the middle and plucking it on the 1/4 part. Okay. So we have seen the change in frequencies when we pluck a string at different points. And when we vibrate it at 1/6 of its point, then we will have a frequency 3 times the natural frequency. So the frequency at that time will be 3n. So there are 3 modes of vibrating a string. One is by plucking it in the middle. Second, by plucking it at a point 1/4 from one end. And third is by plucking it at a distance of 1/6 from one end. So we get a frequency. In first case it is n, in the second case it is 2n, and in the third case we can get 3 times the frequency. Now we come to the next topic, that is the damped vibration. As you know, damped vibration, the name itself suggests that the frequency is going to decrease. Okay, so the periodic vibrations of a body of decreasing amplitude in presence of a resistive force. So when we vibrate, suppose we are vibrating the string of a, we are just pulling the branch of a tree and we are trying to vibrate it. What happens? First it vibrates with a larger amplitude, then it becomes smaller and smaller. So that is the case of a damped vibration. So remember, damped vibration means the amplitude keeps on decreasing. The amplitude of motion decreases due to frictional forces which the surrounding medium exerts on the body vibrating in it. Okay, so that is the reason for the damped vibration, because the air is trying to resist it and it is making it of less amplitude. You can see in the diagram also how the amplitude is decreasing. See, then the frictional force at any instant is proportional to the velocity of vibrating body. So more is the frictional force, then the more will be the dampening effect. Okay, and the body will then move with a lesser velocity. Then so here, as a result, the vibrating body continuously loses energy. So here there is a great loss of energy. When the body starts vibrating, it might have a large amplitude, but then there is a loss of energy. Now we come to difference between free and damped vibration. So that is very important. You see here, the amplitude of free vibration remain constant. This first point is very important, that in case of free vibration, the amplitude remains constant and the vibration continue forever because there is nobody to stop it. Okay, it will go uninterrupted. But in the second case, you see damped vibration, the amplitude of damped vibration gradually decreases with time. Ultimately, the vibration ceases. So ultimately the vibration will stop. So you see, if you vibrate a pendulum, it will start vibrating with a large amplitude in the beginning, but after some time the vibration will become of lesser and lesser amplitude and finally it will cease. Then there is no loss of energy in free vibration because from beginning there is nobody to stop, so we are not losing any energy here. But here in each vibration there is some loss of energy. So here in each vibration there is some loss of energy in the form of heat. Then no external force acts on the vibrating body. So there is no force. The vibrations are only under the influence of a restoring force. So again and again the vibration keeps on continuing. But here frictional or damping forces act to oppose the motion. So there is air which is trying to resist the motion of the pendulum. The frequency of vibration is equal to the natural frequency. So here we will say when the body is vibrating, it is vibrating with its natural frequency. Here the frequency of vibration is less than the natural frequency. So it is not able to move according to its own capability, but it is vibrating with a less frequency. Okay, so these are the example of free vibration and damped vibration. So if I am just taking an example, if you are trying to study without any interference, you can do according to your maximum capacities and you can study well. But if there are many dampening forces, or maybe some friends who wants to take you to distract you and call you for some other activities, then you won't be able to perform as much as you can. So that will become damped. Okay, so don't let the frequency become damped. Study well and try to score the maximum. Okay.